this one HT input vector. This is the input vector. RNN state update and output. Input vector RNN state target output YCAPT update hidden state HT tank HE WT HT minus 1 plus WT X HXT. This one are here. This one input here is updating hidden state. Okay. Time HE weightage positive. Present value. RNN state update and output. Here output vector. This is the answer. YCAPT equal to output what will come W transpose HY HT. This is the output vector. Input vector you know solve it. Updating system hidden state this one. That we have seen. RNN's computational graph across time. Input vector xt time at the rate of time across time. Computational graph. YCAPT RNN equal to represent as computational graph unrolled across time. This is represent computational graph unrolled across time. Across time means t at the time of t. RNN's computational graph across time. Forward pass. Input vector, output vector, RNN state, hide layer, we can say computational graph across time. These sample same weight matrices at the every time step. Same weight matrices every time step. WXH X0 here. These are input vector. These are output vector. This is RNN hide state. But here what mentioned same weight matrix. Same weight matrix means this is the WHY, 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 WHY and all the L0, L1, L2, L3. Here also WXH, WXH, WXH. After the input. After RNN, WYH. Here L0, L1, L2, L3 getting L. RNN from scratch. This is also another library. Scratch. SCRET. Here X of t input vector recurrent cell HT output vector Y of t. Class my RNN cell layer. This is TensorFlow. This is Keras library layers dot layer. Always start anywhere in this text flow, TensorFlow TF definition only. So insert that means definitely definition start, TF start. Self RNN units, comma input underscore dimension, output dimension. RNN units. Self. Super. My RNN self underscore empty initial underscore open close bracket. Initialize a weight matrix SH, HH, HY, self, or weight both. A first SH run units input dimension. Second one in HH run units run units, that is here run dimension is run RNN units. Third one HY same everything. Dimension run units, this one will change. Initially is hidden straight to zeros. So self hidden to make hidden straight to 0. So initialize self dot h equal to tf zeros RNN units comma 1. Now hidden straight to zeros. Initialize automatic. Definition call self comma x. Update the hidden state. Self dot h tf dot math dot 10h self dot w underscore h self h plus self dot w underscore sh dot x. This one xx sh sh here hh here hy here only. No dimension. Compute the output. Output equal to self hy here only. So output what is self dot w underscore hy conversion self dot h. This is the output. Here will come. Now this is the self h. This self h result will come here. So h result will come here. So this is the output. We can. So return the current output of the hidden state. Return the current output and the hidden state. So return output, comma self dot h. RNN implementation in TensorFlow. RNN implementation in TensorFlow. In TensorFlow, tf dot keras library, then hidden layers, symbol RNN, the RNN units. This one from here. Keras layers. This one also layer also here only in hidden. Run RNN units. Save RNN record cell. So RNN is for sequence modeling. One-to-one vanilla NN binary classification. X, Y, output, input. Okay. Many to one. Sentiment classification. One-to-many text generation, image caption, text generation. One-to-many. Like this. One-to-many text generation, image caption. Here, in many-to-many translation forecasting, music generation, one-to-one. This music can be able to hear this music can be able to hear like this. Many-to-many translation or forecasting music generation. And many other architectures and applications. Sequence modeling design criteria. Sequence modeling design criteria. That is a sequence. The model sequences we need to hand variable length sequence. Handle variable length sequence. What is the meaning? Variable length sequences to be handled. Second, track. Which one you have to track? Long-term dependencies. You have to be track. Maintain information. For what purpose? About order. Maintain information about order. Share parameters across the sequence. Share parameters across the sequence. Current sequence parameters to be shared. Recurrent neural networks RNNs meet the sequence modeling design criteria. Recurrent neural networks RNN meet the sequence modeling design criteria. A sequence modeling problem predict the next word. A sequence modeling problem predict the next word. A sequence modeling problem predict the next word. This morning I took my cat for a walk. Sequence modeling problem predict the next word. This morning I took my cat for a walk. Given these words. The sequence modeling problem predict the next word. Predict the next word. This morning I took my cat for a walk. Given these words. Predict the next word. The morning I took my cat for a walk. Given these words. Predict the next word. A sequence modeling problem predict the next word. This morning I took my cat for a walk. Given these words. Predict the next word. Representing language to a neural network. So, deep learning neural networks cannot interpret words. Here, neural networks require numerical inputs. Neural networks require numerical inputs. Okay. Encoding language for a neural network. Encode language for a neural network. Deep learning neural networks require numerical inputs. Natural networks cannot interpret words. Natural networks cannot be interpret words. Embedding transform indexes into a vector of exercise. Transform indexes into a vector of exercise. Vocabulary corpus of words. This my eye. A cat took I morning or walk. Indexing. This is corpus of words. This indexing. Word index A1. Cat 2 walk in. Here embedding index to a exercise vector. One